So you can see, when you come back and watch the recording and go how we go from each stage and which link I just clicked to do different analysis, and so maybe useful. But I kind of like how he said that with AI companion thing, and I seem like somebody's picking in our lecture, and it is between me and my students. I do not want to have any additional tool to look at our things and summarize. I don't really want that. Okay, so let's get started. So from the Tuesday class, we covered theoretically what is a correlation test and what is beyond the correlation test. So what is the regression test? When you want to do regression tests over correlation tests, that's what we talked about. And then now using the real world national data set, let's run correlation test and simple regression model. Okay, so and then I will explain what numbers you're gonna use and how you're gonna report, and is there any additional interpretation you can do with it. Okay, once we done it, I want you guys to just go do your own project and do really just make some good progress, at least during the class session today. Because the next Thursday, you need to submit your variable description, cleaning, and as well as the variable polarizations table. Okay? So last week we used ANS dataset. So this time let's use GSS dataset. So pull it out GSS dataset from our Canvas course site under file. Okay, so you can go step by step with me, or you can watch that, but you have your data in front of you. And meanwhile, let me share my PowerPoint. Okay, might be better share with my screen here. Okay. All right. So you are able to open GSS data set. Great. All right. So I will go over once again because your next stage of the project, I want you to do, let's do cleanup. And then run as the fourth stage. Once you list every variable as your dependent independent variable, and then I want you really use SPSS software, see whether your variable is clean, whether you know general information about each variable using descriptive statistics. So I will go over slowly what I meant by, for example, in your assignment for the number 4, when I ask you guys to do descriptive statistics, okay? And so let's actually use some variables, and you can play with a lot of different variables, but we used some of these, numerical, and interval variables when we talked about central tendency. Okay, so I want to use the same variables to run both correlation and regression model. Okay, so both the correlations and regression model, now we don't like move away from the group comparison or condition or time comparison. Instead, we want to know among and between the interval variable, there is any sort of a relationship. That's what we're gonna look at. So both the variable we are looking at as what we just visited in statistic roadmap, it should be interval in numerical variable. So why don't you use ideology? It was quoted from 0 to 10. So 0 as left and 10 as right. So smallest value goes to the liberal, and the largest value 10 goes to conservative. So though you think it's more, can argue that it's ordinal. However, it goes as from 0 to 10 as in scale, right? So we can treat as integer variable, and as well as what was this? Uh, since just I tried to find some better variable, but I think it's still good variable for us to visit. American, we are leaning to more nationalist approach versus as you guys are international relations guy, and whether we're more leaning to as the world leader and just go with a support idealist approach. So the variable actually might gonna stand out from GSS data set is whether American we should follow our own interests. We care more about our interests over world well-being or reciprocal relationship. Rather than that, just we should focus on what we exactly how Trump administrations are focused on America first approach. Okay, so maybe ideology and this nationalist approach and leaning in their attitude, maybe they are related or not. If that is our research question, this will be great one to use. So in order to clean data, that's the steps you need to do. Okay, that is due next Thursday. Right, next Thursday, yes. Let's see whether the variable we are looking at is clean enough. So left or right, that is left and right. Okay, so right here. And then GSS data set did a pretty good job coding how the missing is missing. Okay, so right here. And then GSS data set did a pretty good job coding how the missing is missing. So here 0 from left, 10 to right. And then there's a missing case is a missing. Okay, so seems like it's clean, but as what the assignment asked, number 4, you should run descriptive statistics. So when we talk about descriptive statistics, it's numerically two different things: central tendency and variability. So I will show you once again. Okay, so in order to run descriptive statistics and see whether it's clean, and that's what you're gonna copy paste from SPSS output to maybe Microsoft Word to what you submit to as the assignment. Okay, so go to analyze, and then we go to descriptive statistics, and then go to frequencies. Okay. So go to analyze, and then we go to descriptive statistics, and then go to frequencies. And as I mentioned that, just leave the frequency table it is. If we detect anything unnecessary or missing cases are listed as a valid value, then we should go back and re-clean it, the variable. Otherwise, that's good to go. And let's see. Left and right, that is the variable we want to use. Okay, so once you move the variable, your variable under the variable section, that means you want to do whatever you want to do. Okay, so go to statistics, and when I say descriptive statistics, it's mainly, I'm sorry about that. Why just keeping up? I have a 3 different screens here. So when I say descriptive statistics, it's 2 things: central tendency. Here it said a dispersion, right? But it is a variability, in other words. But in SPSS, they say as a dispersion. So this is a numeric and integer variable. So you can report the mean, median, mode, right? That's all the valid central tendency for integer variable. And also, since it is numeric variable, you can find the minimum value, which is 0, maximum value, which is 10. And then with that, you have a mean value and you know the distance. So you can select all these variability value here. So select them all, okay? This is a central tendency and variability included, together, that this is a descriptive statistics, okay? That is what I'm saying here. And continue and say, okay. All right. So now we have a statistics table. So it said, okay, mean is a 5, mode is a 5, mean is a little higher, it's a 5 of, 33. Okay. And then let's see the frequency tables. All valid cases are from all the way 0 to 0 is left actually. And they only could right as 10. So these are all valid value and everything else coded as a missing. So it's clean. So you're gonna copy paste of this table and that table and then report that as the fourth stage of the data, descriptive statistics. Okay, that is it. And then now the next variable I want you guys to look at is our view about nationalism, realism versus idealism. Okay, so let's go to this variable, American. This is the variable. So we're gonna look at whether American should follow its own interest. And then when we look at the value, okay, it said, yeah, I strongly agree. Agree, neither, disagree strongly. So that means closer to lower value, the more nationalist view. Getting larger value, strongly disagree strongly, that means it's against the nationalist approach. So it's more of idealist approach, right? So you make sure that when you have a higher value and lower value, just understand those connotations. But if you really want to use it more intuitive, if your hypothesis is about nationalist view, or nationalism, then you may want to do reverse coding, right? That's where you can do under transform and into the different variables, like I'm sorry, right here, right there. Okay, recode into different variables. That's where you can recode for data cleaning. I'm sorry. Then you more of this is the variable. So we're gonna look at whether America should follow its own interest. And then when we look at the value, okay, it said, yeah, I strongly agree. Agree, neither, disagree strongly. So that means closer to lower value, the more nationalist view. Getting larger value, strongly disagree strongly, that means it's against the nationalist approach. So it's more of idealist approach, right? So you make sure that when you have a higher value and lower value, just understand those connotations. But if you really want to use it more intuitive, if your hypothesis is about nationalist view, or nationalism, then you may want to do reverse coding, right? That's where you can do under transform and into the different variables, like I'm sorry, right here, right there. Okay, recode into different variables. That's where you can recode for data cleaning process. But here I wanted to make sure this is clean enough. And I think Dylan's case, you're gonna use the ANS data set. There may require more data cleaning because they didn't really put missing cases as a missing. But Raher's case, if you use a GSS data set, it's pretty much cleaned up in a way, but you wanted to make sure it's really clean before you move on to main analysis, okay? So here I wanna go to descriptive statistics and go to frequencies. Now reset, and what I want to do here is I wanted to measure American own way. And then go to, again, statistics. And again, this is integer variable, numerical variable. So you can select all of this. But if you have a nominal variable, yes or no, male and female, if that is the variable, only central tendency you can select is what? Mode, right? Because we cannot find median or mean value across different categories of people, right? That's problematic. Okay, some part of the world out there, you can say, yeah, man is better than female. Some part of the world out there, yeah, a certain ethnicity, we are majority, so we are superior. You can argue that without any penalty and problems and social political pressure. You can say that, but in here, in our soil, we want to respect those differences. Okay, so mean median doesn't make sense, right? Okay, and then also it is a numerical variable. You can select all these variability value, but again, for if you have nominal variable, you cannot run any of those variability tests. Okay, so only value you can run for nominal variable for your project. It's only mode. Okay, so variability means you should know exact differences between your own case and the specific case from the mean value. If you don't have a mean, there's no way you can find any distance, right? So that's the reason. Okay, and then continue, and okay, let's see whether it's a clean. All right, so here we go. This is a statistic value. So out of the 5 scale, strongly disagree, and strongly nationalist approach and strongly idealist approach, the median mode both are 3. Okay, and mean is a little lower than that. And by the frequency table, we know it's clean, right? All valid cases are the way it is coded, and all missing cases are coded as a missing. So it's a clean. So you can copy paste to your submission. That's what you can do. Got it? All right, so this is what you're gonna do for the data cleaning and descriptive statistics. Now, I wanted to move to run correlation test. Since we confirmed that these variables are clean and we know some tendency, so now we can move on the main analysis. That is actually almost the last stage of your project, and not this stage of a project you're gonna submit in the next week, but once we clean the data, the variable, that is the following stage. So which analysis is appropriate, which information we should report, that is something we're gonna still work on for the rest of the semester. Okay, so in order to run, since we have 2 variable, right? Ideology and nationalist view, okay, whether they are related. If this is your hypothesis, you're totally fine with just going with the correlation test, okay? So in order to run Pearson correlation tests that we covered on Tuesday class, where you need to go to analyze, okay? And then you can see correlate and 2, 4, 6, it's 8 on the drop down box, and you can see bivariate correlation. So between 2 variables, that's where you're gonna go for Pearson correlation test. Then if there's you click that, there's a new pop-up window. It already by default, it already selected a Pearson correlation test. Okay, so now you move 2 inner variables to see they are related or not under this variable section. So the first one was American all the way, and the next variable we're gonna look at is left to right. So we want to know between these 2 in our scaled variable, there's any kind of relationship going on. Okay, so let's just go ahead and run and see what numbers they provide and how we can interpret the number. Okay, so now you see it's just simple enough. Okay, that's what we see. So Pearson correlation test, and then it had, of course, when you say American should, it's the same variable. Correlation will be 100% one, right? But what you're gonna look at is these two variables, the diagonal side, whether they are correlated. Why it doesn't go away? Okay, here we go. So you see it's negative. So from the discussion we had at Tuesday class, correlation test can tell you the direction of relationship. So it's negative. So if you're, but making sure just theoretically, lower value in ideology it's liberal and higher value is conservative, and lower value in American nationalism, okay, and then higher value is anti-nationalism value. So having that in mind, oh, there's a negative relationship, and look at the p-value, the probability for null hypothesis. Again, whether you're gonna say which is a null or not, no correlations at all, then they're gonna test it, it's almost 0%. Okay, so that's the p-value they represent. So almost probability for null hypothesis is correct, which is there are no correlations. So having very small p-value for null hypothesis means yes, it is statistically significant. People's political ideology is correlated to international, more of the foreign policy view related to nationalism versus idealism. That's what you can say. And this value negative means you can now go deeper because we know how we coded. So as people's conservatism getting stronger, if people are getting more conservative, their views related to nationalism gets stronger. Okay, it's negative. Okay, so it can be confusing in the beginning, or you can just say, well, people are getting more conservative, and or oppositely, if people are getting more liberal, then people tend to be more idealistic about international, foreign policy. That's what you can say. But as I mentioned, that's the plain English how you can interpret it. But value you need to report is R equals negative 0.36. 3.4 or something like that, and p-value is less than 0.05. And then when I say, okay, if you want to make a little bit more intuitive interpretation, I was telling you, you can use a square the value of R, okay? So use a calculator. What is the square the values of 0.34 or 0.336? What is the square the value of 0.336? I can do that. Also, you can do that as well. So that means it is R square value. That is some sort of the way you can make a better intuitive interpretation. So R square value represent that how much the variability can be explained by one variable for the other variable. So what is the value of just square the value of 0.006? 0.336?
0.112896.
Thank you very much. So that's what I got here too. So when I have R square value 0.11, let's use that for the better interpretation. That's how much variability and changes explained by one variable. 0.36, 3.4 or something like that, and p-value is less than 0.05. And then when I say, okay, if you want to make a little bit more intuitive interpretation, I was telling you, you can use a square the value of R, okay? So use a calculator. What is the square the values of 0.34 or 0.336? What is the square the value of 0.336. I can do that. Also, you can do that as well. So that means it is R square value. That is some sort of the way you can make a better intuitive interpretation. So R square value represent that how much the variability can be explained by one variable for the other variable. So what is the value of just square the value of 0.006? I mean, sorry, 0.336?
0.112896.
Thank you very much. So that's what I got here too. So when I have, okay, point R square value 0.11, let's use that for the better interpretation. That's how much variability and changes explained by one variable for the other. So in other words, okay, 11% of Americans' nationalism, a nationalistic view, can be explained by political ideology. And also it's a correlation to variability and changes explained by one variable for the other. So in other words, okay, 11% of Americans' nationalism, a nationalistic view, can be explained by political ideology. And also it's a correlation test. You can interpret it, an opposite way. So 11% of the nationalistic view. I'm sorry, that's what I said. Yeah, 11% of political ideology can be explained by people's nationalistic political view. Okay, so it can go either way because it's a correlation, so we don't care which one is the independent or dependent variable. So the R square value, it really represents how much changes and variability can be explained by the other variable. That's what you can use as interpretation. Okay, you got that? Any questions about correlation test?
Would we need to also graph it out like visually? Like for instance,
Not really, it's not really necessary, but you can do with the graphing, and there's a scatter plot you can run. Then you see some of the scatter plot I showed you, right? So it's optional, and usually it's not required, okay? But if you want to, you can go to graph, and then you can just run scatter plot. That's how you can run those numbers. Okay, I mean those graphs that I ran. So we have a time, and we can run that. Let's go to scatter plot and then define and simply go. And of course, we don't identify an independent dependent variable here, but let's say usually the political view goes as a dependent variable. Let's just whatever. It doesn't matter for the correlation test. And then you wanna say what was it, left to right, right? That is variable. And then you can put title and make it a different color or sort of that, things like that. And let's just see. Okay, so you see this scatter plot. The reason is that we have a lot of cases. So what I'm gonna do is that, okay, since it is the additional things that I want to show you beyond the textbook, we want to just, in order to run scatter plot, okay, the too many cases, they actually so crowded, so they kind of block them, so it doesn't show much. So what sometimes you can do is that go to data, okay, I want to select the case, here. And then I want to say here you see random sample of the case, right? So you can select the random and how many, just to be just clear, in order to run scatter plot with a more reasonable visualization, usually less than 300 cases and around 200 cases, they represent the best. So when we look at the it is a case of like a 5,000 or something like that. Let's just simply run it's maybe 5%. I wanna select the case. Select the case here. And then I wanna say, random. Here you see random sample of the case, right? So you can select the random and how many, just to be just clear, in order to run scatter plot with a more reasonable visualization, usually less than 300 cases and around 200 cases, they represent the best. So when we look at the it is a case of like a 5,000 or something like that. Let's just simply run it's maybe 5% and percent. So let's say maybe 5%. I wanted to make sure it's the exact sample size. Okay, I wanted to make sure data view, and then let's go to it's 5. This is okay. So in order to have 3,000 cases, so in order to have about 200 cases, we wanted to have maybe 6%, right? About right? Okay, so let's do that. All right, go to sample once again, and let's just say 6%, and then continue, and then okay. And then let's go to the same place, go to graph and scatter plot. And then let me run again. Maybe now we can see the better. It's still a little bit funnier. Okay, so let's play it more. Okay, but that's in a way you can make it a scatter plot. Okay. And also, I will show you in the regression model, there is also a way you can do that as well. So maybe I wanted to. Let's actually try once again. Select the case and random, and maybe I want to do maybe 4%. And let's see whether we can do that. And let me try once again. That's usually how it should work. Okay, so let me actually just do with the different variables. I think there is something that we can use. Okay, but let me come back. But I wanted to make sure we do regression model first. Okay, and let's just go back to okay, select all variable once again in order to run regression model. So go to data. And now select the case, and I want to select all in order to run regression model. Okay, And then we are here. So in order to run regression model, let's go to analyze again. Now, in order to run regression model, it usually goes back to your hypothesis. And now, your hypothesis really understand the theoretical background. So ideology oftentimes ended up as independent variable. Usually political attitude usually ended up as more of the outcome and the result and consequences. So having that idea, your hypothesis is not only whether they are related, but your hypothesis is ideology can actually predict the people's nationalistic political view. If it's your hypothesis, okay, then it should be regression model because we assume there is a correlation. I mean, there is a causal relationship, right? So, to run regression model, go to regression, and then let's go to linear. So, usually model, let's go to analyze again. That we can use, okay, but let me come back. But I wanted to make sure we do regression model first, okay? And let's just go back to, okay, select all variable once again in order to find regression model. So go to data, and now select the case, and I want to select all in order to run regression model. Okay, data to okay, select all variable once again in order to find regression model. So go to data, and now select the
assignment.
case, and I want to select all in order to run regression model.
Yes.
Okay, and then we are here. So in order to run regression model, let's go to analyze again. Now, in order to run regression model, it usually goes back to your hypothesis. And now, your hypothesis really understand the theoretical background. So ideology oftentimes ended up as independent variable. Usually political attitude usually ended up as more of the outcome and the result and consequences. So having that idea, your hypothesis is not only whether they are related, but your hypothesis is ideology can actually predict the people's nationalistic political view. If it's your hypothesis, okay, then okay, so let me actually just do with the different variables. I think there is something that we can use. Okay, but let me come back. But I wanted to make sure we do regression model first. Okay, and let's just go back to okay, select all variable once again in order to find regression model. So go to data, and now select the case, and I want to select all in order to run regression model. Okay. And then we are here. So in order to run regression model, let's go to analyze again. Now, in order to run regression model, it usually goes back to your hypothesis. And now, your hypothesis really understand the theoretical background. So ideology oftentimes ended up as independent variable. Usually political attitude usually ended up as more of the outcome and the result and consequences. So having that idea, your hypothesis is not only whether they are related, but your hypothesis is ideology can actually predict the people's nationalistic political view. If it's your hypothesis, okay, then it should be regression model because we assume there is a correlation. I mean, there is a causal relationship, right? So, to run regression model, go to regression, and then let's go to linear. So that's what we covered from Tuesday class as a simple regression model. So go to analyze, regression, and linear. then you're gonna put now as what we can usually use ideology as independent variable. We're gonna put that in under independent variable, and our dependent variable about the nationalistic view that was American view. Okay, so that's what you can do here. Let's see, it's the same variable. Let's see, there is some plots we can run from here. So I want it, they actually use not the rather than the exact lines of the linear line they try to run, but we can use some of the residual. Residual means you can actually it's like a variability across the line. Okay, so that's what you can run with it. I usually like to use dependent variable here, or just residual. Here you mean the z means it's I didn't really explain in the theory. So z means it's a standardized value of z, and how based on the standardized the z value, how the residual fluctuating. That's what they do. Okay, so rather than that, just what about just we can simply run this with dependent variable. No, maybe let's do with that. Yeah. Standardize the residual. Then it's not the scatter plot actually Dylan was looking at. It just to show the across the line how that it's gonna change. But maybe we can just see anyway. Okay, let's do that. All right. So let's look at the model first. Okay, model first. So this is what you can see right here, right? So across the regression line, how the actual values are as what we saw as the error around that like a regression line. Okay, so if you want to report that, that's totally fine. And this is a residual going around the regression line as well. So depending on how what is the focus of your research, you can report the different thing. And sometimes they have a flat line as the regression line and how it just showed and up and down. And also you want to play with it. You want to find the best way you can. But anyway, that's a visualization that is not required for any of the statistical analysis in any of academic paper. But sometimes, especially for the meta-analysis, across all different studies in the field, how they fluctuating in terms of error and sample size. Sometimes this, the graph visualization could be useful. But anyway, come back to regression model. As I mentioned that when we run a regression model, we use two different values. One test is that for each slope, okay, at this time it doesn't really make sense because we have only one independent variable, but especially next week we're gonna move, we have multiple independent variable, that each of those slope and each of those independent variable, whether they are significant or not, it's by t-test. And then overall, the equation model itself, it is significant or not, we use F, table, F distribution to see whether that equation model is statistically significant or not. So let's look at here, coefficient. Coefficient means it's a slope. Okay, when you see slope, whether you are left or right in your ideology, is that really, it predicts people's nationalistic view? And look at the t value and p value. T value, it's negative value, as well as the correlation value, they are negatively related. Is that statistically significant? Yes. A smaller p value represent that it's almost a zero probability for null hypothesis. That means independent variable predicts something about dependent variable. Okay? So, but here, when you come back to the B, this is a slope, okay? The slope in the regression model that is different from the correlation value is it is a rho slope. So you can actually use this slope value for better interpretation. In other words, okay, let me just try it. So the ideology is a scale of 10, and your nationalistic view, the political attitude, that's a scale of 5. So let's have that in mind and just see what I try to tell you. You can understand it. So what this means is that it is those two inner variables are negatively related, but how much you can use it since we know the unit. So when your political ideology increase by 1 unit on the scale of 10, your nationalistic view, okay, actually it is negative. So it is increased by 0.138, 0.14 on a scale of 5. Or vice versa, you can say when your political ideology is increase, move to more conservative view, conservative ideology on a scale of 10, your real idealistic international view will increase by 0.14. That's how you can use this rho number, rho slope for interpretation. Okay, but as I mentioned that now we can make interpretation based on the causal relationship. But another beauty of regression model beyond the correlation model is, let me actually, so just remember briefly what we have here as the v value and slope, and then y. And so what we need to understand is that what is the constant. So I will just show you how to write up. And I don't know, can I show like two screens at the same time? But let me try. Let's just come back to here. Let me share whiteboard. Okay. So how to write up actually your equation model. Okay. The best way I can do is that use this one. Okay, I can type it better than writing. I mean, drawing. So let's say equation model you can write up is y. It's a dependent variable. So political view, whether it is nationalism versus idealism, right? Realism versus idealism, that's your dependent variable. And then, as I mentioned, that the equation model is the beauty of a regression model. You can find the purpose of a regression model is to find alpha and beta value, A and B value. So A means is a baseline. So if there's nothing to do with ideology, what will be the baseline for American to see a nationalism view? That is 3 point, that is a constant and alpha value right there on the table, 3.650. That's alpha value. If your independent variable is 0, nothing to do with this equation, then it is. And then it is a negative relationship with ideology scale we have. It's gonna be 0.138. Next. So this is equation model. We can write up out of regression model. So in the future, if you know your x variable, now you can find people's attitude about nationalistic and idealistic view. If you know the idealistic view, your dependent variable value, sometimes you can go back and find their ideologies at the same time. So this is equation model and equation model for the simple regression model. So it is a sort of a beauty of the regression model that you can report in your Visual 2 section. Okay. So I am done covering correlations and regression model, how to run it. So now, rest of the time, I want you guys to visit your own variable and let me go over if you have any question. So I do not want to force you, show me something. I will be here, okay? And you kind of look at and go into your data set and just go to your variable and try to clean up and do some descriptive statistics, and then I can answer any question between them. All right. So again, Rahul, just try to go to your data set and variable, do descriptive statistics. Okay. So I can see what I can help. Okay. For the rest of the class today, and then making sure for the next Thursday class, during the class session, I want you guys to do most of the assignment done. Okay. That's all I want to do. Okay, so go ahead. It's more of the one-on-one individual lab session. I want you guys to do. Wow, so let me explore some of those scatter plot and how it can show you it better. Okay, so you do your own thing. I'll do my own thing. So meanwhile, since it's your own project, let's leave the recording as it is. So maybe you want to watch it again.
So this is interesting.
Okay.
When I ran, so I had the two statistics on two variables on SPSS, which were, it was whether or not the national economy was better or worse than last year, and then whether or not the country would be better off if we just stayed home.
Mm-hmm.
And I think if I'm reading this correct, the Pearson correlation is 0.304.
Mm-hmm.
And then the p-value is less than 0.001. So that's a
Statistically significant. But at this stage, I don't expect you to really decide what test and do any result. Yeah. But just I wanted to make sure you have the correct variable to run. Okay. But when you say that's a strange or weird, what is a strange?
Well, I mean, not strange. I was just trying to, I guess not strange. I was just,
So
I didn't
based on the result, it is statistically significant.
Mhm.
Okay, and then just since you talked about that, can you show me your variable, and you can share ANS data set and see your variable.
Like both variables or?
No, just share your data set and just show me the variable. You can go. We can go to the variable together and just see.
How
This
I,
is
Share.
Sure, you can go to the bottom of the Zoom screen. There's like a green button, share, and then it let you share your file that is open.
Oh yeah, I'm having. My computer always glitches out when I try to share.
Okay, it's fine. I think that was what's happening.
Yeah, it's my Mac.
Okay, all right, I see.
Weird. It doesn't. Hmm. Yeah, I don't know why my computer doesn't.
Okay, so then no worries, and you don't need to. But I wanted to make sure that you clean the variables without problem. Okay, you can run those variables descriptive statistics. So when the first variable, okay, you said it's correlated, but I can confirm. So your first variable, how they are coded?
I need to go back. Hold on.
Mhm. Meanwhile, Dylan is just try to go back to the data set. And the way I try to show you the scatter plot, that's exactly how it's supposed to be. And as well in the textbook, as well as in practical, things about somehow with this large data set, this scatter plot doesn't really behave. But the way you want to see is beautiful, like dots and scattered dots around. But it just kind of chunk them together in each incremental, the values of 1 to 5 and 1 to 10. But sometimes if you have the variables from 0 to 100, okay, it's really, really large, and then some significant and then limited sample size around the 200, it will show you the way it's supposed to be in a scatter plot, okay? But that's where you can run, and now you can go and to run the scatter plot. So just I want to reconfirm that's what you're going to do. But sometimes if you really see chunk of things, it's just a line, and you try to reduce the sample size because these two data set is too huge, right? So then you can see just random sample, case selection, and then run it again, and that's how you're gonna do it. With a smaller sample size, I can see a little better, but still it's not quite the way I wanted to see. Okay, so just make sure for your independent variable or dependent variable, it's a numeric, then just make sure that you run the proper descriptive statistics with all central tendency and variabilities. And also if you use the variable as a nominal variable, how they are coded, it doesn't matter, right? 1 to 5 or 1 by 10 doesn't matter. But if you use those variables as more of an inverse scale, make sure they are coded in a proper manner. Okay, that's what is regarded as a part of a data cleaning process. What about Rahul? You don't have any question about like data description and running some of those the descriptive statistics, and do you have any questions about your selected variable?
No, ma'am, I don't have any questions.
Okay, so you're doing well and you are pretty making good progress. Yes? Until, this is toward next 3 weeks or so. So don't worry about it yet.
Yeah, I'm gonna try to fix my computer too, so I can actually share my screen. I don't know why.
Yeah.
My Mac. I mean, I think I had SPSS open, and then my computer just doesn't. I don't know. It's weird.
Yeah.
I'm not very.
It happened last time again. So I don't know whether the way I understand SPS is not really made for the Mac. It's just based on the PC. So sometimes it glitches with the Mac system. And then also SPSS really requires huge space to run. So it could be the reason, but I don't know why even you can share it with on a Zoom meeting. That is strange. Meanwhile, me, I can stop recording since it's not going to be some.